Welcome. So I don't want to go through all the multiplication. We can. If I want to determine the end behavior of this, I can multiply these two, then multiply everything times x squared. But remember, when I'm multiplying, or when I'm looking at a polynomial and I want to determine the end behavior, all I'm concerned about is that leading term. Well, I know that the leading term, remember, is going to have that highest exponent, right? Your degree. So a couple things I can do is if I multiply these out, I know that my leading term is going to be x times x, which will be x squared. And then I'm just going to have a whole bunch of other stuff. And then it's going to be multiplied by x squared again. So if I apply this through multiplication, I know that the highest term again is going to be x to the fourth. So I'm not really concerned about everything else that's going to be going on through my multiplication. I'm only going to be concerned about this leading term, which I can determine is going to be x to the fourth. By knowing that it's x to the fourth, my degree is even, my leading coefficient is 1 and positive. So therefore, my graph is going to rise left and rise right. All right, now to determine the zeros, I take my f of x, set it equal to 0, and say 0 equals x squared times x plus 5 times x minus 8. Now what I need to do is find the values of x that make this true. Well, since I have a product equal to 0, I can apply the zero product property. So say x squared equals 0, x plus 5 equals 0, and x minus 8 equals 0. Now I solve each one of these individually, and I can say x equals 0, x equals negative 5, and x equals 8. Now what I need to do, and actually real quick, let me actually write this one other form. I could also write this as x minus 0 squared times x plus 5 times x minus 8. Now I write it in this format when I'm looking at my multiplicity. You don't have to write in this format, but I want to explain to you, when determining the multiplicity of your zeros, you need to go back to the factors and see the degree kind of pretty much on each factor. Well, by writing x squared as x minus 0 squared, you can see that this factor has an exponent of 2, meaning the multiplicity of the 0 is actually 2. So when looking at the multiplicity, these have a multiplicity of 1, and this 0, too, has a multiplicity of 2. And remember, when the multiplicity is even, it touches the graph, and when it's odd, it's going to cross. So there you go, ladies and gentlemen. That is how you determine your multiplicity. Thanks.